Welcome back, Physics 30. This is the part 2 of this CO1.1 section. So as I mentioned in the other video, the cosine theta factor appears in the equation, and it is the vector component that is parallel to D. So as we saw there, ladies and gentlemen, it's the one that is going to give you F parallel that is parallel to D. Work is a scalar quantity, has no direction, only magnitude, but it can be positive or negative, as we'll see. So yeah, this paragraph here just talks about what I talked about on the previous page. So yes, even if my force was parallel, that's an angle of 0, and for math class, of course, the cos of 0 is 1, so it would just simply stay as F times D if it was parallel. But otherwise, if it's being pulled at an angle, it would look at that horizontal component that's parallel to D. Force can be exerted by an object and yet no work being done. So for example, if you hold a heavy bag of groceries with your hands at rest, you aren't doing work. Because the key thing here, in order to do work, or W equals whatever the force is, cos theta times D. So if we have a force, but if we're not moving, there's no work being done on it. You do force, but the displacement is 0, therefore the work is 0. So even though in the real day sense it seems like we are doing work and holding something up, in the physics sense, lifting something up to a maximum height, that requires work, but holding it there is technically no work being done. Because in order to do work in the physics sense, you need a force and a displacement. So the act of lifting something and having it move, that is work being done, but just holding something up isn't. Okay, if we look at the last page, also doing no work if you carry it and walk horizontally across the floor with constant velocity, as shown on the figure on the right. No horizontal force is required to move the bag at constant velocity. So the force is upwards, and yet we're moving this way. Now this is an interesting case because the angle between here would be 90. And those of you from math class, remember that the cos of 90 is 0. So you would have 0 work. If your force and displacement are perpendicular to each other, no work being done. So the person shown on the right exerts an upward force on the bag equal to its weight, but this upward force is perpendicular to the horizontal. And this conclusion comes from our definition of work, because if that angle would be 90 here, because D is this way, the force I'm exerting is upwards, and the cos of 90 is 0. So that means no work is being done when the particular force is perpendicular to the displacement of movement. When you start or stop walking, there is horizontal acceleration. You do work, but holding it there, you don't. Okay, so even though work doesn't have it's not a vector, it can be positive or negative. So when we talk about positive work, we're going to basically be talking about gaining energy, whereas negative work is going to be synonymous with losing energy. So if we look over here, the work can be positive, 0, or negative. So let's maybe write that. So gaining energy, and we'll put down here object gains energy. Negative object loses energy, depending upon the direction. So if we look over here, now all of these, they use, sometimes physics books use S for displacement. I like to use D though, so I'm just going to change these all to D. D. So let's put those as D. So if force, so the displacement's going this way, so you can see that the force here is going to be in the same direction. It's going with the displacement. So of course we can figure out the component and get what's going to be happening on. So here we have positive work. Positive work. No work, as we talked about. If our force is perpendicular to displacement, no work. And here our object's moving this way. But if our force is this way, It's negative work, so the object is losing energy, so causing a wagon to come to a stop, for example. That would be an example of negative work. So zero work does not affect an object. If we look at positive work, it accelerates the object. It's going to give it some energy. And then, of course, the key thing in there is that the force or component of the force is in the same direction. So as you can see here, if the force here is caused by Fg, then of course we will have F and D in the same direction with this example. Okay, in this one here, we have D going up this way, but my Fg is going the opposite. So my force is, so the object is going to slow down and then speed up coming down. So this scenario will turn into this scenario. So negative work, you can think of decelerates the object, or it's going to cause it to lose energy. And that happens, of course, when our component of force or our overall force is opposite to the direction of movement. All right, so that's kind of an introduction to CO1.1. You should be able to do the assignment now, and we'll see you again.